let's get to talking about coolant flow in a Cummins block. Or Cummins, I guess Cummins head block, whatever. I've seen some videos, and the reason I want to do this video, I've seen a few guys do this. And this is not to pick on anybody. Don't take it that way. It's just that I've seen guys doing it wrong online, and they think they're doing something better, and they're not. So I wanted to talk about it. Figured, why not? So coolant bypass. Well, let's not start with the coolant bypass. Let's start with how the coolant flows through the engine. So all of the coolant, there's one suction point on the cooling system on a Cummins. All the B-Series Cummins are the same way. Well, pretty much almost every engine's the same way, but we're just talking B-Series Cummins right now. So you're gonna have your rad hose goes on here. This is the only suction point. So any point past this is now gonna be pressure. Keep that in mind for later when we're talking. So this is from here, that way, through the cylinder head, all gonna be pressurized. Water pump sucks it in here. You can see my finger. Sucks it in there, pushes it out through this cavity. Everything else, pressure, right? And a lot of people say, oh, well, you don't need a coolant bypass. There's no reason to have one. And that's a yes and a no, okay? I'm just gonna leave it at that. It's a yes and a no. But what I want you to understand is how the coolant flows through it. So going through the block here, I don't know whether I'm gonna be able to show it very well on the video. If you look inside here, there's the coolant passage, right? And if you look, you can see the flashlight shines through here. And this coolant port goes around, and these don't have Siamese bores, which means they're not connected in the middle. It's part of the reason these blocks aren't as strong. Same with the 5.9 common rail. This is a 12-valve block. They're not Siamese bores. A 6.7 is a Siamese bore, so these two pieces are attached to each other, and they tend not to move around as much. So we'll talk about that in a different video. But there's nothing, it's just an open hole all the way along, right from this point, you can't see it that far, but all the coolant can flow however it wants through the block. So it pressurizes here, pressurizes the whole block, okay? There's nothing that promotes flow from this side or from the front to the back, okay? As far as the block is concerned, right now. Now, if we take a head gasket, like you look how big these ports are. Everybody's like, oh, there's lots of coolant flow, right? The reason the ports are that big is not for coolant flow, it's to get casting sand out. So we take the head gasket and we put the head gasket. This is the head gasket that was on this thing, so don't mind that it's dirty and junk. Now you look where all those coolant ports are. Small hole, wow, this is the biggest hole in the front. Small hole, 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 a little bit bigger hole, full flow, right? Now, all of these holes are going into the cylinder head, keeping the cylinder head cool, and then also promoting coolant to go from the front of the block to the back of the block. This is actually for your bypass, but I'll maybe get into that a little bit later. But that's the reason for that. So all these little holes are, yes, it's to let coolant and let air out of the system, but you're gonna get very little coolant flow through those holes in a large fashion, right? This is where all the coolant really is gonna flow from to cool the cylinder head off. So it goes into the cylinder head, up through the cylinder head, all these holes, right? Goes into it, comes out your thermostat, because your thermostat would be right here, right? Comes out of your thermostat, goes to the rad, circulates, sucked back in again. Now, coolant bypass. So that being said, the cylinder head's the same idea. There's nothing that really makes the coolant flow a certain way, other than the coolant is being forced more in the back, so it goes through, comes through. Now, some guys are gonna say, well, why did this cylinder get hot then? Cylinder gets hot because inherently all the coolant coming across here is going to get heated by this cylinder, this cylinder, this cylinder, this cylinder, this cylinder, now your last one, and then all the coolant is flowing, the rest of the coolant is flowing out through here, coming out. So all of the coolant is going to be super heated by all these cylinders, or heated, I shouldn't say superheated, but heated nonetheless from these cylinders all the way down, then the last cylinder. hopefully that makes sense. So the coolant bypass, now this is a fleece style, right? It is a fleece one. I'm actually we're working on making one of these that fits a first gen, because nobody makes one that fits a first gen, and I think that would be beneficial for the amount of guys that have first gens. Anyways, won't talk about that anymore until I get it ready. So your coolant, knock this rear frost plug out. This style has a thermostat in it. You can have spring style one. The spring style one is more of a high RPM unit. So it relieves pressure on the block side of things. Now you can imagine at full nachos, you're gonna have a lot of block pressure because these holes are so small, right? Now, some people are gonna say, oh, you just drill all these holes out. And yeah, you can drill the holes out. The problem with drilling all the holes out is now it doesn't promote the flow to go to the back of the block anymore. So if you're gonna drill one out, I have done in the past, is you drill this one bigger, like twice the size of what it is. These ones I personally leave alone, but you can drill this one bigger, which is gonna help promote more flow to the back of the cylinder head. Now, if you're putting a coolant bypass on, it does the exact same thing. Thermostat gets hot enough, whatever, I think it's set, I think these are 180s. Yeah, 180 degrees, thermostat opens, it goes up and goes into the top rad hose, right? Now, has to go in the top rad hose. Well, it doesn't have to go in the top rad hose. It has to go into the rad to be cooled off, because you've now taken all this hot coolant and you don't want to dump it right back into the engine again, because you never cooled it off, right? You want to take it from here into the top rad hose, so it goes through the rad, comes back. How you get it into the top rad hose honestly doesn't really matter. They put it just into the top. I've made spacers before. I've drilled and tapped holes. I put holes in radiators to do it. Like if you have a complete aluminum radiator, you can do it that way. You can use this to cool off other components. Like if you had an air compressor, which is an industrial style, they have actually goes through the air compressor and circulates around. On a Ford, what a lot of guys do is they'll pull this thermostat out, or you just use an actual block-off plate that has a hole in it, and you feed your heater core with this, which is gonna keep everything moving. The problem with doing that is it's not really designed to have that constant flow right there. Usually you're gonna constant flow through the head, which is technically restricted. Anyways, you can do that. It's just that if you find that it doesn't run hot enough, kind of sucks. And you can't run a thermostat. Well, you could, I guess, but then you're gonna have no heat until the engine gets hot. Which is, if that's what you want, I guess you could put a 160 degree thermostat in here and do that, but then you're gonna have basically no heat until you get to 160 degrees. So here nor there, up to you guys. Now, what I've seen a few guys do here, and I'm gonna insert a picture, and like I said, this is not to make fun or any of that type of stuff. I'm just trying to help guys. If you guys watch this guy on YouTube, you're gonna know who it is. But I watched his video there a couple months ago, and I thought, man, I should do a video on that just so guys understand why not to do it. So here's the picture, okay? So the issue with the way that it's done is the coolant is coming out of here, right? Pressure. There's pressure here. It's coming out and going in here. So if you guys were listening while I was talking, what's here? What's here and here? There's pressure on both sides. So is the coolant gonna flow there? The pressure, let's say, is 25 PSI here and 25 PSI here. Nothing's happening. You're not gonna get flow. Hey guys, hit up the website. I got a bunch of parts, a bunch of merch, cool stuff. Check it out. Let's get back to the video. Really expensive paperweight at that point. You have to go from here to the radiator, or at the very least to a circulating part of the system. Like I said, you can run this to a heater core or something else if you have an external. I've done that with an external radiator. If you have an external radiator, you're trying to get extra cooling. I don't think is the best way to do it. But you can do it that way. You can take this, plumb it into your external cooler, bring it back, and then dump it into the bottom rad hose, because you've already cooled it, right? So, like I said, I just wanted to talk a little bit about it. We'll go over to the cylinder head for a minute too. But if you're doing it that way, it isn't gonna work. So just be forewarned. Anything on the block, and head side, past this point, pressure. So if you're trying to move coolant, you have to take it from pressure to the non-pressure side, which technically anything after the thermostat is going to be non-pressure. I know that's maybe going to confuse some people. It's just that it's not, there's pressure there, but there's not movement. Maybe I should explain it that way. So if you're trying to take coolant out of one of these things, this is pressure. So if this was an automatic, which originally was an automatic truck, but this would usually flow through, it would come out of here, go to the transmission heat exchanger, flow through that, go into the bottom rad hose. Now, if we go over to the head, take the head gasket. So this is where your temperature sensor usually would be. You can pull coolant off here too if you want, and then also both of these are coolant ports, industrial stuff. But you can pull coolant out here. I personally, if you're going to pull coolant, I prefer to pull coolant, if you're trying to, out of one of these two ports, because then you're there again promoting more flow to go through the cylinder head, right? But Cummins does do, they pull full flow off of these ports. So you can pull coolant off them, don't get me wrong, you can do that. Cummins does it, they designed it, so they obviously put some engineering, well, I'd hope anyway. Well, I guess I can't even say that. These engines were really good, but they do have problems. So, what would I want to say? Oh yes, on the cylinder, on the block, right? We were looking at, oh, I got this gasket the wrong way. There's that big one in the back here, right? And then there's this, the little guy, and then this little bit bigger one here. And what I wanted to show you guys is, see, there's these two holes here, right? Hopefully you guys come out of the block, and then they go up through these two holes, right? And the purpose of those holes, if I can lay this down here, not squirt myself in the face with something. Hold on, we gotta move a couple things here. Otherwise I'm gonna end up wearing something. So if you look at those holes, this is a bypass hole. So if you have a thermostat in there that has the double little spring piece on the back, that's the reason for that extra hole. And then this one is just another one that bypasses constantly through there, which is just like a high RPM bypass, basically is what it is. It's trying to bypass extra coolant pressure off. That's what it's trying to do. Well, I shouldn't say trying, that's what it does. Some of them, it just doesn't do enough at certain RPMs. Like if you're a factory RPM truck, it does the job. Problem is we go full tard and crank them up, and then this system is not designed to flow enough at full nacho, and you have problems. Okay, so that's where these holes, when we were looking earlier, they line up with that, right? Which I don't know why they don't actually have, like, why the holes don't line up better. If I was an engineer, it'd be different. But anyways, I'm not an engineer. So that's like on the coolant side of things, like that's why I wanted to talk about the coolant flow. A lot of people don't understand you're going to starve the cylinder head. And it's like, no, these things have more than enough flow. You're not going to starve the cylinder head, because at high RPM, this valve is opening and starving the cylinder head before it even goes through the cylinder head. It's going out of the block directly into behind the thermostat and going back out, right? So if they were worried about that, they wouldn't have this there. So when you put one on the back, that's going to relieve pressure, and then this valve is going to do less work. Now, on most of my stuff, I don't even run this style of thermostat, so it bypasses there all the time. The only thing is they tend not to warm up as fast. So it's up to you. Like I tend to run mine relatively high RPM because I can, so I do. But hopefully this helps some guys when you're putting a coolant bypass on, or understanding a little bit more about how the coolant is going through the block and why it's going through the block that way. It doesn't make sense the way some people are doing it. So I just wanted to talk a little bit about it, because if you're doing it wrong, you're spending all that money. Like these coolant bypasses are not cheap, right? So I wanted to make sure, like if you're putting one of those things on there, I want to make sure that you are getting the benefit of having it on there. Otherwise, there's no point. You might as well not put it on if you're not going to have it hooked up properly, right? So hopefully, if you have it hooked up wrong, hook it up right. If you haven't put one on and you're going to, now you know how to do it, right? And if you have a first gen, let me know in the comments if you'd be interested in one that fits in your first gen. I'm making some because, well, I want to put one in my first gen. I would like to put one in my buddy Shay's truck, and that thing is also going to need one because we're going full nacho with that thing. So hopefully this helps somebody out. If you like this video, check out this one.